Okay, so let's tackle this question. It said a 3 kilogram iron block, that's the mass is 3 kilograms. Said it's heated electrically by a 200 watt coil. So when we talk about watts, we're looking at the unit of power. So power is 200 watts. Now we have time. Time is 6 minutes. So we have to convert this to seconds by multiplying by 60. So we have 360 seconds. And they say we should determine the specific heat capacity of the ion. So from we know that Q is equal to MC change in theta, right? Okay, they said the temperature of the iron block increased from 30 degrees Celsius. So theta 1 is 30 degrees Celsius. Converting this to Kelvin, you have to add 273. This gives you 303 Kelvin. Theta 2 is 40 degrees Celsius, which is 40 plus 273, which gives 313 Kelvin. So Q is equal to MC change in theta, but Q is also energy, which is power times time, is equal to MC change in theta. Making T the subject, C becomes Pt over M change in theta. Now what is your power? Your power is 200 multiplied by your time is 360 divided by your mass. Your mass is 3. Your change in theta is 313 minus 303. So summing this up, we have 200 times 360 all over 3 times 10. This gives you okay. This gives you 2,400 joule per kilogram Kelvin. So this is an example under electrical method of solving of determining specific heat capacity. So the next thing we're going to talk about is change of state. Talk about change of state. Now you have to know that when you change state from solid, which is ice, let's take ice as an example, water as an example. When you change it solid to liquid, it is called fusion or melting. When you change when there's change of state from liquid, let's say water, to solid, you call it freezing or solidification. When you change states from liquid to gas, we call it vaporization. So we're going to talk about fusion, and there's something called latent heat of fusion. So we'll talk about fusion and latent heat of fusion. So now let me explain something here. Let's say you have an ice block straight out from the fridge, from the refrigerator. You take the temperature, let's say 0 degrees Celsius. You place that ice block on a bowl and you allow it to melt to water. Now, after some time, you observe that the initial ice block was 0 degree, right? When this water melts, like immediately after the ice block finished melting, if you check the temperature of this water, it's still going to be 0 degrees Celsius. You understand? So the amount of heat required to convert this solid to liquid without a change in temperature is known as latent heat of fusion. The amount of heat required to change a unit mass, yes, a unit mass of this solid to liquid without a change in temperature is known as the latent heat of fusion. So latent heat of fusion, You can define it as the amount of heat required to convert a unit mass of a substance from solid to liquid at its melting point. At melting point, yes, it must be at melting point without any rise in temperature. Now, the unit for latent heat of fusion is joule per kilogram. Now, we're going to talk about some things like laws of fusion. So, there are laws of fusion, some laws that govern fusion. So, the first law of fusion is that all crystalline substance change from solid state to liquid state at a temperature called melting point. Obviously, you know what a melting point is. When water gets to its melting point, it begins to melt, you understand? An ice block, sorry, gets to melting point, it changes to water. Temperature of the substance remains constant from the moment melting starts until the whole substance has melted. Just like we explained in the previous slide, where we said ice block changes from solid state to water, liquid state without a change in temperature. Thirdly, each substance require a fixed amount of heat called latent heat needed to change the unit mass from solid state without temperature change. This is just the definition of latent heat of fusion. All substances changes its volume on melting. Yes, when we talk about volume, so substances changes volume. I know you've heard of something like okay, yeah, some contract on melting. That's like they reduce in let's say volume. Example is ice, antimony, and iron. Then some expand. Example paraffin wax. When you're melting, these ones expand. Now we go to the fifth one. Melting point of a substance changes due to change in pressure. The melting point here, the melting point of a substance can change, you understand, due to pressure. So for melting, the melting point of substances that contract on melting, that's this one's ice, antimony, and iron, they decrease with increase in pressure. So when you are increasing the pressure, their melting point is decreasing, and vice versa. Then the melting point of those that expand on melting, like paraffin wax, increases with increase in pressure. That's as pressure is increasing, their melting point is increasing. As pressure is reducing, their melting point is reducing. That's basically it. Then we're going to talk about vaporization and latent heat of vaporization. I believe okay, we talked about vaporization in the previous slide. So now if you have water, a bowl of water, and you apply heat to it, let's say you use a Bunsen burner or something, you apply heat to it, and after heating it for some time, it gets to its boiling point and begins to evaporate out of the container. Now, if you are to check the temperature of this water, let's say you have 100 degrees Celsius. If you check the temperature of this vapor, you're going to see 100 degrees Celsius. So the heat required to convert a unit mass of this liquid to gas without a change in temperature is known as the latent heat of vaporization. Okay, latent heat of vaporization. Now, yeah, I forgot to tell you. Remember that I said whenever you talk about unit mass, you're talking about what? Specific. So please include specific to this. This is specific. Similar to the previous definition of latent heat of fusion, please add specific to it. That's also specific because we're talking about a unit mass. Understand? So you can note down the definition. It can be defined as the amount of heat required to convert a unit mass of liquid to vapor without a corresponding change in temperature. Understand? So there are also laws of evaporation or boiling. Now let's look at them. We have the laws. Okay, first things first. To notice that the temperature of liquids remain constant until the whole of the liquid is converted into gas. Exactly what we said, that all of them both the vapor and the water will have the same temperature. Secondly, every substance changes from its liquid state to gaseous state as a fixed temperature called boiling point. Yes, once the boiling point of a substance, when the boiling point of a substance reaches, it begins to convert from liquid to gaseous state. Thirdly, the amount of heat required to change a unit mass of liquid to gas is called the latent heat of. I'm meant to be specific here because of the unit mass. Latent heat of vaporization. Volumes of all liquid increases on vaporization. Unlike the previous one that some of them expand, this one all liquids, all volumes of all liquids increases on vaporization. And the boiling point of liquid increases with increase in pressure. Just as I said, pressure influences boiling point and melting point. You understand? So boiling point of a liquid increases with increase in pressure. So they are directly proportional. As boiling point is increasing, pressure is increasing. As boiling point is reducing, pressure is reducing. So this is just basically the basics of thermometry. Yeah. Thanks for watching.